Start whenever you want.
Yes. Okay. So we started recording. Welcome everyone to the second EESSI Happy Hour. So the EESSI Happy Hour happens every Monday from 2 p.m. to 3 p.m. And it's something very new. We try to get engaged with users, anyone involved with EESSI, to just tell about the topic, tell about some news, but also to just discuss anything related to EESSI. What happens in these EESSI Happy Hours is that we probably share some news about EESSI, what happened since the last EESSI Happy Hour. And we have some topic to highlight we want to tell about. Every week there will be a new topic. Then you can ask any questions. And we want to record this so to make it also available for everyone else. But it could also be that, let's say, you want to discuss something maybe sensitive or so, then we can also stop recording at the end and you can ask questions. Okay, I think that's more or less what I wanted to say at the beginning. The topic of this session today is a walkthrough of accessing EESSI via the EESSI container script. Last week, Richard presented how to install the SermFS client and get access to EESSI via that. Yeah. Okay. Then before that's already about this topic, Kenneth, you said that there's maybe some news to share.
Yeah, well, just like half an hour ago, we finally published the governance documents,
Yes,
let's say, the documentation on how EESSI as a project is governed, is run, how decisions are made, and all of that. So you can find that now in the EESSI documentation.
yes, I can
And we'll
show
make
this
some
maybe.
noise about this in the community as well.
Yeah, I think I can show this at the end of the
Yep, yep.
presentation. Okay, so the session today is about accessing EESSI through a container. So for example, it could be that on the system you work on, you don't have, EESSI is not available via the CernVFS client or some other means, and you have no administrator privileges on this system so that you cannot install it yourself. But it could be that there is a container runtime, Obtainer, available, and then you can use that. Yeah, and this is what we will show you today. So you don't need admin privileges, you need Obtainer. You could also use a recent version of Singularity. You also need Git to download some scripts. And this supports all architectures. What we have listed here is all the production architectures we support, ARM and x86, but it would also work for RISC-V. Just the last thing to mention, this is not really related to this session, is in about a month, we have this Euro hackathon related to the Euro HPC User Day. So just after the Euro HPC User Days in Copenhagen, we have on October 2nd hackathon related to EESSI. And if you want, you can go to this website. You could probably find it also via some Google, or use the QR code and then get information about this. And if I remember correctly, there is about 25 places for on-site participation, and there are still some places left. Okay, I think that's all I wanted to say before I start some demonstration. So I just have to get rid of these controls here. Okay. So what I'm trying to do here is I'm logged into one of the Euro HPC systems, Doikalion. It's in Portugal, and is interesting because it supports different architectures. So it has some x86 compute nodes and some ARM compute nodes. And just to be a good citizen, I first try to run a job on one of the compute nodes. So I will do this for the x86 partition, but also for the ARM partition. That's just, let me see, and just have to wait a little bit probably. Okay. So here now I'm on one of the x86 compute nodes with some AMD CPU. We don't know really, I mean, maybe we could know what this CPU microarchitecture is, but we don't have to care for the moment. So what I need now is I need to get access to this container script. So we have a nice script that you can just run without any arguments, and it just gives you then access to EESSI, to the main software.easy.io repository. And the only thing, of course, it needs is the container runtime and access to the internet. So I don't have it here, so I just have to get this first. You, of course, find this how to do this also in our documentation. I remember this, of course. I just have to type it without any mistakes. Software layer scripts. So I'll now download this, and here I can also do this. Okay, so here I don't have to do it because it's the same directory. We can just go into this. But here I'm on a different node. Maybe I showed you which kind of node this is. CPU. Okay, here you see it's an ARM node, and actually that's the node with the A64X. So I can go here, maybe start here because it takes a bit more time. Here there are many scripts we use for building software, and this also includes a script easy container. I can just run the script to get access to EESSI. Yeah, maybe I should actually maybe on these nodes I'm not sure. There is maybe actually EESSI and it's already available. Yes, here it's already available, but I will use that to show you some difference. So let me do this. Using container. I run this with all kinds of output, and we will look at this a bit later on. And here, this is on the other node. I can also check if I have EESSI here. Is this? I also have it here. Okay, that's maybe a surprise. Let me then. Okay, so I will not run any codes. I go back to the login node because I think I don't have it here. Yes, there's no SermFS. But so let me go here. But here I want to get access to it. Yeah? The only difference is I should not run any simulation on this machine later on. I also do this here with verbose to show you what is in the output. So what you see here is it basically fetches the container image from the registry. And this is where you can find the images. And there are images for ARM, for x86, and for RISC-V. But you don't have to know which one does it automatically for you. We can maybe check here. Okay, so this takes a little bit of time until it is loaded. You see what happens in the background is that it uses some local temporary directory and creates one for you. So you don't have to specify this. You can, of course, but you don't have to if you just want to have it sec. And here, what's maybe also interesting for later, it tells you after we ended the session with the container, you can add a parameter -- resume and then the location for the temporary directory. And then it will it can resume from that session we have run before. Let me check if that is done. Okay, so this looks good, and this is on the login node. So here we didn't have access to SermFS before, and now we have. Yeah, and I will do one thing in addition. I will also init this script for easy. So we have some init scripts, and I will use one for bash. So it's almost done initializing easy. And so what happens here is this init script detects what kind of CPU I have on this node, and then just sets all the environment variables so that you have access to easy. So now I could check what modules are available, and I would see that all these modules that are listed below are available from easy, from the SermFS repository, and they are for Zen 2 for the architecture. If I go here, then it takes a little while again. Yeah, so probably have to wait a little bit. It's a bit slower on this machine. Check. And of course, I could also load a module here. Let's say like and so flow. Back. It's not. It takes a while on these A64FX nodes. Load. Okay. Yeah, I can load the module here. I don't want to run any code on the login node. But yeah. But what I actually wanted to show you is maybe I just scroll a bit back here. So there's a lot of output here. One interesting command is basically this one here. And here we just say how we run actually the container. And what we do is we fuse mount two repositories, SermFS repositories, one with configurations for other repositories. That's this one, cvfs-config, and then the easy repository. And we bind mount them into the container so that we have access then in the container. And maybe what I could run, I just go out here, I start again the other job. Still waiting here. So I just do this again here. It's the easy container. Web rows. Yes. Okay. So maybe it looks a bit surprising that it always fetches the container, but as said in the beginning, it creates a temporary directory for this run. And unless you tell it where to find the cache directory for the images, it would always use the one that it's creating. And then there's always a new one. Okay, so now it's mounted. Let me check this command where it runs the container. Ah, yeah, okay. So here it's again basically the same command. Okay. And here I have access, but of course you could argue, okay, is it actually what comes from the host, because the host also has easy, or is it from the container? Not bash. So let me check. Oh, no. Okay, so this is also ready now. So when I run this on the ARM processor, it's basically again the same command, and just to type this. Sorry. Okay. So the difference, there's not much difference, but what you see here is basically, let's say this line first. Yeah, the script detects what kind of architecture you have, and then configures the environment accordingly. So what I wanted to show you, but let's say the module environment looks uh, the same, as we have shown you probably in the last happy hour also, is that the environment looks the same. Yeah, sort of more or less the same modules available. There are a few differences, maybe like 5 or so difference, because not all software that is available for x86 is all available for ARM, but the differences are very minimal. So what I could do now is to show that it actually works. I could just, okay, so I'm just going back into the directory here. I could clone, we have a repository with demos. I clone this. Sorry. Demo. Okay, so if we clone this, I will also do this. What he, So now if I go back here, what I see is I see the software as scripts directory. Yeah, so that's what I had, but it doesn't show the demo directory. And that's because it creates this temporary directory and then also has a temporary home. One can configure the easy container run so that you have, for example, access to your normal home directory. But we don't have done this. So what we can just do is you just also clone the GitHub repository with the demos. So, and now, so if you go to the demos here, yeah, so there are a couple of demos. Last time we used Gromex. Problem a little bit for the A64X is that we don't have Gromex yet for A64X. So if you do this, then it's not shown. So we can use some different demo, and I think that TensorFlow should probably work. So I just go into this one. So here, there's just a run script, some documentation. So the run script is very simple. It just what it's doing, it's just checking if we have access to the repository, what version it has, what we have initialized, then loads the TensorFlow module, and then runs a test script. So we could just do this, see what happens, and we can also do the same here. Let me check. Okay, I have to go to this demo, TensorFlow, and then just run this. And then wait. Now I download some scripts for the for TensorFlow, and of course it also has to download some tests, and we have maybe wait a bit. And while maybe we are waiting, we can get some questions. If there are any questions or comments, let's say. While we are waiting, and there may be some comments, of course, one could check what options the script has. There's also some documentation. So if one goes to the EESSI documentation, let me see if I find the home page for this. So if you just go to easy.io/docs, then you get to the documentation. And here, if you go here, installation configuration, then last week we talked about the native installation. Today we talk about a sort of container installation, or how you get access via container. And so there you see some familiar steps what I did, and then just running the script. So you don't, in the easiest example, you don't have to add any arguments. However, the script itself comes with lots of options, arguments, so for all kinds of scenarios. So the script itself, we also use when we build software to be added to EESSI. Yeah. But we don't want to go into these details right now. Yeah. So it's always good to check the documentation and also check just what arguments you can provide to the command. So let me check if something is happening here. No, there's nothing happening. Okay, maybe the demo gods are not with me. Are there any questions?
Well, just to comment, TensorFlow is a very expensive example because you need to, what was it again? 1.1 gigabytes of data and 3,500 files, I think, just to run and import TensorFlow. So there's a lot going on in the background now. It should eventually go through and it's caching all of that data.
Yeah, maybe I just put something here. That's just the VM. Do I have this? Yeah. Let me see.
And meanwhile, there's a question in the chat actually,
Yeah.
whether the software that's being used coming from EESSI, whether that caching is happening within the container or not. So where is that data actually stored, the cache?
Yes. So SOMFS needs cache. And in this temporary directory, there are directories. Maybe that's something I could actually show if I thought, no, that's not here. Then I will do this a bit differently. So then what I do here is here on this system, I have SMFS already available, but I just clone the repository. So there scripts. I'll also do it here, and then you go into this directory, and maybe I also do the repos here. Let's see if that works. So under this directory, there will be a directory structure put in place, created, which contains all the temporary directories, including the directory for the cache of SOMFS.
And there's actually options available in the script as well, so you can specify where those go.
Yes.
If you want to have a persistent cache after you exit the container, rather than just reusing that random directory.
Yeah, so TensorFlow is a very expensive example.
Yeah, this is now taking quite long. Well, this is on Tucalin, right? We know the internet connection on Tucalin is not fantastic. So.
Yeah.
Although they have, well, okay, you're in the container, so that also means we're using the generic ServVMFS configuration. So that means you're actually bypassing the local mirrors that they have on Tucalin as well.
So what
which can make it quite slow.
Let's see if I see that here. Yes. So as mentioned, there's this home in the temporary directory, but there's also this directory. I guess that's the one that is interesting. So if I look here, so no, there's only this one. Then probably I just have to jump out. Sorry for this, but I just have to grab the temporary directory. Yeah. Let me look into this. Try to show you what I want. So, yes. Yes, okay. So here, what you see here is var libcmfs and var runfs. CMFS. And the cache is in the lib, so we can just look to this one. And normally when you install this on your system with the CMFS client, then they're under separate var/spool, I think. Yeah, so you have here shared. Then you see sort of the directory structure for the CMFS cache. And then maybe, I'm not sure if that is seen here. Yes. So what you see here in this line is that it bind mounts what is under this temporary directory, this path into /var/lib/cmfs, and that expects by default where the cache is. Yeah. So for every container session has its own cache. And I guess that's also what you want, right? You don't want that the two sessions probably running in parallel interfering on the cache. Okay, finally. So this is the one on A60FX. So this has run. And
if you rerun it now, it should be a
yes,
lot faster because everything is cached.
I was just thinking about that. So it was about 7 minutes on Zen 2. It was about 6 minutes, and we can also try to rerun this here. Yeah, okay, here you see it's already starting. So it's much faster than the first run, but that's also expected because first run, nothing was cached. We run a container, so the cache is empty, and we don't run a specific proxy that could have cached information. So this is much faster now.
This actually highlights one of the things that that is important compared to the last happy hour where Richard demoed a native installation of ServVMFS, which is in some sense better because then you have a persistent cache on the client where you're accessing easy. Here you're already seeing some of the caveats if you don't have a native installation. Like it does work, but you're bypassing some things and some things can be slower. So it hampers the user experience a little bit.
Yeah.
It will still work, but it's just less of a pleasant.
Yeah, and of course, if, for example, if you have a cache for the container image itself, then could already start faster, not this step, running the demo, but yeah, the first step could be faster. Here, this step would not run faster, yes, because you cannot benefit from an existing cache. You can't, or maybe you should not reuse the cache.
But it's still useful because as long as you have Apptainer installed on the system, which you typically need admin privileges for, that's enough. So yeah. all that you need is Apptainer, and then you can start playing with easy. So essentially, the ServVMFS installation itself is in the container image, so you don't need to talk to your sysadmin to get actually access. So it is still useful, but yeah, you typically would do this for very extensive production use, especially large scale workloads. You wouldn't run like this.
Okay, and here what you see is also that it is also faster on A64FX, but not as fast on Zen 2 nodes. Okay, that's all I wanted to show. No more questions. I don't see the chat at the moment. Let me see. I can try to get the chat. There are more questions, more comments.
Yeah, there's another comment from Richard. So that means that the temp storage used should take into account the cache size, which might increase based on the software in use. Yeah, so wherever you put the temp storage, you have to make sure there's enough room there for the cache. Yeah. So if your temp/temp is very small, you may want to pass another path to the container script. I think it does have that option, right, Richard? Thomas, sorry, to use a different temp directory, or maybe just setting the temped environment variable is sufficient.
Maybe I can just jump out here and also just run. So there are many different options for all kinds of things. There is an option for storage. Let me see if I find.
Yeah, you passed it.
Yes. Yeah. So here you can log, for example, if the default /temp is not big enough, or for other reasons, you could provide a specific directory where it starts creating these temporary directories. And then, yeah, there are many different options. Maybe one other thing, maybe you remember that it was relatively slow at the beginning, so I could maybe, let's see if I have it here. No, probably not here. Just have to see where the initial output was. Sorry for scrolling. Yeah. So if I just pass this argument for the temporary storage, it will just reuse the temporary storage from the last session. And then it is much faster. It doesn't have to download the container, it doesn't have to convert it, and so on. It is much faster. And yeah, then I can again start. So, and the nice thing here is also that I have history in my home. So I can just, this is now the history here is local to the container run. So I can also use that. And then again, I have access and can check what I have here. And of course, that's much faster than other questions.
I don't see any other questions right now, but maybe as a spoiler for the upcoming sessions, there's other ways of accessing Easy as well, right? So
Yeah.
last week, Richard showed native CERN-BMFS installation and configuration. Now we have Apptainer or Singularity and our container image, but there's other ways as well.
Yeah. So maybe I could show you just this page. It's also in our documentation under training events 2025 happy hours. You see information about happy hours. Here we have the recordings from the happy hour last week. And also the slides are there. And then we will also upload the recording for today. And yeah, next week is the topic other ways to access. So other ways means you don't have SermFS natively installed. You don't have possibility to run a container for some reason. Yeah. And then what to do, how you can get access to Easy.
Maybe even just a thought until next time. What if there is no internet on the node? So maybe we'll tackle that in the next session.
Yeah, so what's going on in the background here, as soon as you start running something like TensorFlow or GROMACS, if it's not cached yet, CERN-GMFS will download that from a mirror server that Easy is hosting. And of course, you need internet access for that, but there's ways to get around this as well, or to be prepared for that. No spoilers yet.
Hey.
Good. Yeah. Does anyone have any questions, any comments either on this specifically or
Yeah, I
broader?
guess we do have in the chat. There's a question in the chat.
Yeah. Okay. Question for the future session. Yeah. Okay. My use case is on Kubernetes. Rail. What's Rail, Daniel? Can you clarify? I don't know if you can unmute.
Yeah. Rail is just implementation we have at UIB for Kubernetes. So it's our local deployment. And sort of another part to this question is I've tried to use the image made by this script and that didn't work. I'm probably doing something wrong there, but the question here is if we would be looking at the CVMFS CSI driver for Kubernetes, or if that would be unnecessary for EC, if that's like more intended for other modules in CVMFS.
I think it's a good question. It's very relevant to what we talked to here, especially if you tried that image and it didn't work. I think the reason it didn't work is when we launch our container with Apptainer, we do a fuse mount of the /CVMFS file system. So one of the options that you can get exposed to when you do the dash repose is it does fuse mounting. So it actually uses the CernVMFS in the container image to mount an extra file system when the container is being started. And that's what you need to do. So CernVMFS is a fuse file system, so you need to have that mechanism there. I'm not sure if that's possible. I'm not familiar with Kubernetes at all. I only know on a very high level what it does. But there are indeed ways to use CernVMFS in Kubernetes as well. I'm not sure if the CSI thing is the standard way of doing this, but I know they're doing this in CERN, for example, where CernVMFS was developed. So it's definitely possible. It's definitely well supported.
Yeah, that's so. I think that's they're using the CSI driver there. So essentially, that's just a module you install on your Kubernetes deployment, and then that makes CERN VMFS available in all the containers on the specific node that you are running. Yeah.
Then that should work with easy as well. I mean, beyond that, we don't do anything weird or special that wouldn't work. You would have to try it, but I expect it to work.
Yeah, my question is sort of the opposite. If this would be overkill for EC, if EC is so simple that it's this wouldn't be necessary.
So to some extent, easy is just a bunch of software installations that are built in a very specific way that they can be used on any system, ARM, x86, and then we pull some tricks to make sure we control the libraries so that they're not coming from the host operating system. So whether you're running Ubuntu or CentOS or whatever, we don't care because we're not going to use the libraries that come from there. So we pull some tricks, but all of that is about the contents of the CernVMFS repository at the very basic level. And mostly what we're talking about here is you're getting access to the contents of a CernVMFS repository by mounting a fuse file system.
Yeah.
Once you get beyond that, it doesn't matter. As soon as you can access the contents of the file system, you're good to go. And for this, in a Kubernetes context, it looks like you indeed need this CSI driver to get access to the file system. Once that is covered, it should work fine.
Yeah, I can follow up.
So it's not overkill. It's necessary essentially, unless you have a different way of
I was
the
about to
contents
mention
of easy and exposing that to the
another way to do it is to mount the file system on the node, like doing the CVMFS mounting on the node itself, and then putting that through to the container.
That would work. Yeah, then you need to be careful how many containers would be using that and how different workloads they would be running. Yeah, but to some extent, that's closer to a native CernVMFS installation that you would see on a cluster, where you can also have lots of different jobs hammering or using that easy mount.
Yeah, thank you.
Yeah, so I mean, one good way of getting support for easy, getting help, is joining the Slack. There's an easy Slack. And especially if you're playing with things like this and you're stuck or you have questions, that's a very good place to ask questions, and you'll get quite quick and good answers there, I think.
Yeah, great. I'll follow it up once I touch on this the next time. So yeah, thank you.
All right.
Good. Other questions, comments, wishes?
Wishes, lots of wishes. No.
Wishes for
I think it's good that we make sure we stick to the planned timing. So max 1 hour, that we definitely stick to that. It doesn't look like we're overrun today, but that's important for these.
I have a question for Daniel. Daniel, do you think this question you asked might be something we can plan a dedicated session for to further discuss in Easy Happy Hours, or it's just some personal thing you're looking into? Like, is it general case in Kubernetes where we can share our experience? We can invite some people in the Easy Happy Hours to dedicate a deeper look into this, or?
I would say that's more of a question to you as a group. This is my first time in this happy hour thing. If you have a lot of users who are using Kubernetes and wants to have running this in Kubernetes, it would probably be very interesting. But if it's only me, then I think Slack is a reasonable avenue as well.
I'm thinking it might also be nice to, I mean, once you figured it out, Daniel, to see if we can add a documentation section on this, like how to make this available in Kubernetes. And then
Yeah.
it could be as simple as install the CSI driver and that's it. But at least it's good for people to know that that's necessary.
I think there's actually people in Basel in Switzerland already doing it through Kubernetes. So Pablo Escobar, that some people here know, and not the drug lord, but a regular guy, has probably been doing this with in Kubernetes. What is it, pods, as well. So he's in the EESSI Slack. So if you ask any question that mentions Kubernetes, he'll probably notice and jump in. But we could involve him in a session like that as well if there's interest. So
Okay.
I suspect you're not the first one trying it, Daniel. There have at least been others, and certainly with CernVMFS, getting access to CernVMFS repositories in general, there's a bunch of people that have experience it. So yeah, I think Richard is right. It could be interesting.
Yeah.
Yes. Okay. Thanks a lot. Then I think I can close the session.
Yeah. I
Hope
think
to
we
see
can wrap up.
some of you again next week.
All right.
Yeah, same time
Cool.
next week. So every Monday.
All right. See you.
See you.
Thanks a lot, Thomas. Bye-bye.
See you. Thank you.
Thanks for joining.